As a veteran of the film industry, when presented with a question on our final project, I decided to stick with something that was a little bit close to heart. And the question I wanted to find out was, does the age of a lead actor or an actress affect its movie ratings over time? This is an analysis of the International Movie Database data presented by Chris Flowers. To start off with an agenda, I'm going to go over the overview of the status quo, the data procurement phase and the cleaning that I did on the data, the statistical analysis, as well as a visual analysis of the data, and finally, I'll end up with a summary and a conclusion of what I found out. Now, the status quo, as I see it now, is lead actors are usually given a lot more leniency than lead actresses when it comes to age in film and television. The common belief is that age, coupled with gender discrimination, leads to actresses getting fewer major roles in higher rated films. Now, this leads to my hypothesis, which is there a statistical reasoning behind this based off of ratings, age, and the year of a movie's release? Now, to start this journey, I had to get the data and figure out how I was going to govern that data. And I ended up using the IMDb public databases with over 6 million data points. And I happened to use 4 different data frames that included a multitude of different areas that I needed to compare. These data points being over 6 million was way too much for Excel to handle. So I needed to extend my knowledge and start learning R. Now, in order to do this, these data frames, luckily, IMDb built them in a way that they each had a constant to connect them if needed for research like this. Now, this T-const, as what they called it, allowed me to really keep the integrity of the data complete as I went through this journey. Now, 6 million data points is a lot to deal with. So I really needed to weed out all of the external outliers and the factors that didn't really matter to what I was looking for. So what I needed to do was I organized the data by filtering it by categories, specifically actors and actresses with a few lines of code, and then moved on to finding out the lead's age by subtracting the birth date by the release date of the film, because IMDb doesn't show the age of the actors due to a lawsuit that was filed against them. Finally, I created a dummy variable for is female, which represents whether or not the actor or actress is female in a computing aspect, because a computer doesn't know whether or not actress means female or actor means male. Finally, my data set ended up being over 130,000 observations with 14 variables, 12 of those coming from IMDb themselves, and 2 of them coming from me with the age lead, as well as the is female variable. In order to run this statistically, I needed to figure out which variables I wanted to run against. So for my dependent variable, I decided to choose the average rating of a film, and then to see if the X variable, if female, had anything to do with whether or not a rating was higher or lower. And judging by that, and as you can see from this regression that I ran, the t-stat as well as the coefficient and the p-value are way outside of the norm as far as being able to accept the hypothesis that being female has a lot to do with the average rating of a film. Moving on to the 2 variable regression, I kept the y variable or my dependent the same with average rating, and then I added the lead's age in addition to whether or not they were male or female. Now, this did alter the t-stats and the estimates as well as the p-value a little bit, but not enough to really make it statistically reasonable to accept the null hypothesis that the age of a lead actor or actress and whether or not they're female or male has anything to do with whether or not the public will rate a film higher or lower. Finally, I wanted to figure out if we could figure out this stuff visually. So I decided to take the average of age of a lead and graph it against the respective year of release date. And as you can see, for about 50 years in the middle, there was a median age of about 35. And then all of a sudden, around the late 90s and early 2000s, there was a big increase in acceptable lead ages that the public would, or that studios were casting. My personal opinion is that this is because of the adoption of the internet. And basically, my reasoning behind that is for years before, major publications and media outlets were in charge of who would get the public's eye. And with the invention of the internet and social media and search engines and all of this great technology coming to the forefront in the early 2000s and late 90s, this really gave a choice to the public of who they were going to follow and how they were going to follow them. Going a little bit deeper into my actual hypothesis to visualize it, there does seem to be an age discrepancy between male leads and female leads that have been cast in a film, and it is about 10 years on average going through the years. But luckily, the trend is still the same towards those later years with the adoption of the internet. Visually, you can kind of see that these trends may be flattening out and maybe even diverging from, or maybe even converging and reversing course on each other eventually. But we still need more data in order to see that. So I also needed to plot whether or not the ratings were affected over the years. So in order to do that, I took an aggregate of the average user ratings for a film and the release year and plotted them out over time. And as you can see, the line is pretty flat and normal throughout the history of reviews. So it kind of backs up the thesis that age and whether or not a lead is a male or a female does not have an effect on whether or not the movie does well in ratings. But an interesting point that you can see from this is that since the public adoption of the internet, there has been an exponential amount of growth of actual data points of reviews done by the public. So you can kind of see how this could influence those former graphs with those growths that we are seeing in the early 2000s and the late 90s. So finally, a visual summary to kind of sum it all up and bring it through to the hypothesis is that the ratings over time in this flat line of around in between 6 and 7 on average per movie over time does not equal the graphs that we see of the average age uh, of lead actors over time in both the male and the female categories. So in conclusion, the data wasn't sufficient enough to analyze the hypothesis statistically as well as I would have liked. There weren't enough variables to show. I think having box office data as well as some other variables would be a lot more significant in whether or not the aggregates are, I'm sorry, and whether or not the data was accurate or not in the model. But I do feel that there was a more useful analyzation of this data through it visually, because statistically it backs up what we came through visually. And while the ratings stayed the same over the years, there was a consistent trend of a high average age in the lead actors and actresses. And going back to my personal thesis, I do think that's contributed to a connected and open world due to the internet and studios not being able to choose who gets the public's attention thanks to social media. Thanks for listening. Here are a few citations of where I got my data sets from, and a huge shout out to Max Woolf for the inspiration on this presentation. Wouldn't have been able to do it without him. And thank you for listening.